Hello and welcome back to Joe's Math Tools. In our session today, we are simplifying an expression where there's a coefficient involved and we have constants within our parentheses. And if you're ready to see how this is going to be done, let's get started. So in simplifying our expression today, we are working with a coefficient. And I know for those of you who may be a little bit more advanced, if they are looking at this example, you know that there is another way that you can simplify this expression without using the distributive property. But remember that we're focusing on our distributive property. So that is the steps or the process that I am going to be using to simplify this question. So remember that when using your distributive property, this means that our term outside of our parentheses is multiplied to everything inside of the parentheses. So this means that my 3q will be multiplied to 6. And then 3q will also be multiplied to 9. And as always, of course, we are going to work through simplifying our expressions within our parentheses at the side first. And then if any simplifying can happen afterwards, it will be done after we've worked out our brackets. So let's begin with our first parentheses. We have our 3q being multiplied to 6. And remember that our 3q simply means that 3 is being multiplied to q, which is being multiplied to 6. So we're now going to multiply our numbers together. So 3 times 6 will equal to 18, and 18 times q will equal to 18q. So let's return our answer back to our expression, making sure that we return it back in the position of our bracket that we moved it from. So now let's simplify our second bracket. And we have our 3q being multiplied to 9. And again, 3q means that 3 is being multiplied to q, which is being multiplied to 9. And we're multiplying our 3 times 9, which is equal to 27. And our 27 times q will equal to 27q. And we're going to return our solution once again back to our question. And in working through this question, you'll notice that in this case, we do have like terms within our expression. And remember that we have like terms not because the numbers are alike. Remember that our coefficients or our numbers in this case can always be different, but it's our variable that tells us whether our terms are alike or unalike. And since both of our variables are both q only, when I say only, that means there are no other variables attached to our terms. So it's just q, and both q's has the exact same exponent. So because both of them are alike, they are considered like terms. So because my variables are like terms, that means that I can now go ahead and add my coefficients together. And in adding my coefficient, that means I'm going to add 18 plus 27. And once we would have summed these numbers together, we will now return our 45 back to our answer. And remember that when adding our numbers, we did have an additional part of our answer or additional part of our term within this question that must also be returned to that final solution, and that is my q. So remember that in adding our numbers together, we also had a variable attached to this solution as well. So that means that we must return that q back to our answer to make sure that it is summed the correct way. Okay, so when 18Q was added to 27Q, we got the sum of 45Q. And this would be our solution in its simplest form. Okay, so there you have it. We did simplify this expression where we had two constants within our parentheses and we were focusing only on our distributive property. And yes, there may have been another way to simplify this expression using PEMDAS, but remember that this is a distributive property series, so we are sticking to our distributive property rules. But as always, get some additional practice in, and we'll see you right here in the next session on Jules Math Tools, where the aim is always to make math easy.